All right, today we're going to look at graphing rational functions. Rational means fraction. So we're going to be looking at graphing fraction equations. We are going to be doing the graphs on our calculator partly, but there will also be some things that we need to consider by hand or in our minds ourselves that the calculator doesn't show us precisely. A rational function is a fraction function. So it will be something of the form of something else. They may sometimes just be numbers. They may have variables in them. But we have something over something else. So that P over Q means that we just have something divided by something. Sometimes they have x's, sometimes they don't. So the most basic example of a fraction function is 1 over x. And that is the graph of 1 over x. It creates what is called a hyperbola. A hyperbola, not a hyperbole. Hyperbole in English, extreme exaggeration. Hyperbola in math is a graph that has two branches. So that means that we end up with both a horizontal and a vertical asymptote. So in our last chapter, when we were looking at logs and exponentials, it had one or the other. Hyperbolas will have both a horizontal and a vertical asymptote. It will create two separate pieces that are not connected to each other because they don't cross those asymptotes. And they will always be diagonally across from each other. So you should expect to see one curve in one corner and then in the opposite corner another curve. So we're going to begin by graphing on our calculator. So on our calculator, we'll go into y equals, clear anything that we have in there, and type in the equation. Now when we do this, we need to be careful with the bottom. So I'm going to do -2, and I have to use that little negative, not the subtraction button, but the little negative to make a negative symbol. -2 divided by, and then in parentheses, x plus 3. It's important that you put those parentheses because that's what tells the calculator that we're dividing by all of the x plus 3. Otherwise, the calculator would just divide by the x. So if there's more than one thing occurring in a numerator or denominator, you need to make sure that you put parentheses around that. And then after that, I still have to do a -1, and make sure you use there the subtraction of 1. The only time you should use that little tiny negative is if it's the very first thing you're typing. Otherwise, use your subtraction. So we hit that in. Now your screen might be off-centered because of other graphs we've done in the past. So for the very first time we're graphing here, I'm going to suggest that you go to Zoom and choose choice 6, which says Zoom Standard, and that'll just put all of us looking at the same exact thing. I hit enter and I get this. Now, your calculator might look slightly different than mine because mine's actually making a little bit of a mistake here. Remember I said a hyperbola should have two separate branches that are disconnected. My calculator is trying to connect them. Okay? So yours may or may not have that little line in the middle. If it doesn't, that's actually good. There is a way in different settings and stuff that we can change that, but we're just not going to worry about it. We're going to know that, in fact, those two pieces should not be connected. Okay, so from what we can see in our graph, then, is our two branches are going to be in the upper left and lower right. What we need to do by hand is find out where the asymptotes belong. So, to do that, in the equation, what number would cause a big problem if I plugged it in for x? -3. Plugging in a -3 would be a really big problem because -3 plus 3 is 0, and dividing by 0 is a big problem in math. So that gives us our asymptote, that x cannot be -3. So at x is -3, I get a vertical asymptote. Some of your homework questions will just ask you to find asymptotes in domain and range and not actually require that you graph. So make sure you read your directions carefully. So if on this question we were asked to state our asymptotes, our vertical asymptote would be at x equals -3. It's the number that doesn't work for x. If I plug in a -3 for x, I divide by 0, and that is a big no-no. I'm going to explain two different ways to think about how we find the horizontal asymptote here. Some of you may click better with one way, some with another way. So I'm going to give two different ways here for how we can find a horizontal asymptote. The first way to think about why the horizontal asymptote exists. A fraction is equal to 0 when we have 0 over something. Right? 0 divided by some number should be 0. The fraction in this problem is never going to be 0 because it can't ever be 0 over something. It's -2 over something. So since that fraction will never be 0, this thing will never be 0 minus 1, or it will never be -1. So that second number there gives us our asymptote that we're never going to get -1 as an answer for this. A second way of thinking about it is building off of what we've done several times this year in thinking about shifting. If we consider shifting in this equation, what does that -3 do? Or sorry, the x plus 3 do?
Move it to the left 3.
Goes to the left 3 spots. So if I go left 3 spots, I get an asymptote. And what does that -1 do? Down 1. So if I go down 1 spot, I get an asymptote. So we can think about shifting here to create the asymptotes. Or we can think about the values that would cause us problems. Plugging in a -3 would be a problem, and getting a -1 is an impossibility. So our horizontal asymptote would be y is equal to -1.
Is there just eyeball?
Eyeballing is dangerous because they might not always be whole numbers. So on the calculator, we can kind of use the calculator to get an idea of what it looks like, but they might not always be whole numbers.
Is vertical always x?
Vertical is always going to be x. So then once we know where our asymptotes are, we can just sketch in what we see on the calculator. So we see that we have one up in that corner and one down in that corner. So we can just sketch those in. Then domain and range. Domain speaks about x's. So as I look at my x-axis, I have an arrow pointing out to the left. I have an arrow pointing out to the right. I'm going to get everything to the left, I'm going to get everything to the right, except at -3, so I'm not going to get -3. So our domain is x is not -3. We will get every possible number for x, but we cannot do x is -3 because that would make us divide by 0. So what do you think about range?
It's not -1.
Y is not -1. We've got an arrow that points downward. We've got an arrow everything along that y-axis except the one spot where those two pieces break apart. We're not ever going to get a -1. So again, for some of your homework questions, it just asks you to find those 4 things: the domain, range, vertical, and horizontal. Okay? And then you wouldn't need to sketch your graph at all. But some also ask for the graph. So read your directions carefully and do the pieces that it's asking for. Questions? Let's do another example. So I'm going to go in and clear the equation from the last problem and put in this new one. 3 divided by, remember in parentheses, x minus 1. And then plus 2. You always need to group up if there's more than one thing happening in a numerator or denominator. And then we can just hit graph. And we can see that this one is happening in the upper right and lower left, so that gives us an idea of our two pieces, but we need to find where those asymptotes are happening by hand. So for a vertical asymptote is going to come from a problem with x. What number is a problem for x? 1. So our vertical asymptote is going to be at x equals 1. If I plug a 1 in for x, it would cause me to divide by 0, which is the biggest no-no in math. For the range, two different ways to think about it. We could either think of the fact that this fraction will never be equal to 0, so I will never get an answer of 0 plus 2, or 2. Or we can think about shifting, and that plus 2 at the end would cause this whole thing to bump up 2 spots and give us an asymptote at 2. So our horizontal asymptote is at y equals 2. Then we can just sketch in the two pieces that we see on the screen. Domain and range are the not equals versions of our asymptotes. So x is not 1 and y is not 2. Domain is always x's, range is always y's. Questions? Yes.
So when we're graphing this out on the paper, does it really have to be specific, or can we just make it so it's not touching?
You can just sketch in those two branches. The asymptotes I want precisely placed, but as far as where the branches are, you don't need to worry about specific points. You can just sketch those. This is the first year that I've graphed them on the calculator. In the past, I've made students do XY charts and think about shifting and stuff, but this year we'll just take them on the calculator. There's one other type of rational or fraction function we're going to look at today, and that's when x is on both the top and the bottom. When x is on both the top and the bottom, this is going to be a different type of problem for us. And in your homework, they're kind of mixed up. So it's not all the first type and then all the second type. So watch out. If x is on both top and bottom, this is a different thing going on. We can't just think about shifting then, because are we shifting according to the x that's on the top or shifting according to the x that's on the bottom? And then how does the y shift? So shifting can't work here. When we have x on both top and bottom, our vertical asymptote is going to be where the denominator is equal to 0. That's the same thing that we were thinking about in the last one. What would cause us to divide by 0 is still going to be a problem. The horizontal asymptote is at the fraction of a divided by c, where a and c are the coefficients of x. So our horizontal asymptote, we're just going to grab those numbers that are in front of the x's and say that's going to be our horizontal. So we can't think about shifting here. We can just grab the coefficients. So for these, our equations have x's on both top and bottom, so that means when we put them into the calculator, we need to be careful with the way that we enter. I need parentheses around x plus 1, and then divide that by parentheses around 2x minus 4. Then we still need to think about the asymptotes by hand here. On the last slide, it said that our vertical asymptotes are going to occur where the denominator is 0. So I'm going to set 2x minus 4 equal to 0 and figure out what number is a problem. So I add 4 to both sides, and 2 is a problem. If I would plug 2 in for x, I would get 0 on the bottom of the fraction. That's a no-no. So my vertical asymptote is at x is 2. On the previous slide, it said that our horizontal asymptote is going to be at y equals, take the fraction of the numbers in front of the x's, so that would be 1 over 2, or a half. So that's why it's difficult to eyeball off the calculator, because we're not always going to get whole number answers here.
Wait, how'd you get 1 over 2?
Take the fraction of the numbers in front of the x's. So on the top, there's a 1 in front of the x. On the bottom, there's a 2 in front of the x. So we just take those coefficients. This only works when there's an x on the top and the bottom. So our first two examples, this would not have worked on because there wasn't an x on the top. Okay? So if there's an x on both the top and the bottom, then we can just take those coefficients. Then we can see from our calculator which two corners it's in, and so we can just sketch it into those two corners. And as before, our domain and range are going to line up with our asymptotes. The domain tells us what x cannot be, and the range tells us what y cannot be. Questions? Yes?
So what's the point of graphing it? Like on our calculator?
So we can see which two corners it's in. It could be in any pair of corners. They're always going to be diagonal, but we don't know whether it's, which diagonal two they are. So we're just putting it in the calculator to confirm which two. And then that should also kind of confirm what we see as our asymptotes. So you can kind of eyeball, and if you think an asymptote is supposed to be at 7 when you do your solving, but the calculator it looks like it's at like -3, you can know you maybe made a mistake. So it can kind of help you with those asymptotes and making sure that you're getting what you think you should be getting, but it definitely lets us know which two corners we should be drawing in. And it should always be two diagonal corners. So if you're seeing a graph that's not looking like that, there's a problem. One more example. So let's start by graphing on the calculator to get an idea of what it looks like. Remembering to put parentheses around the top and parentheses around the bottom. Oops. Then our rules for a vertical asymptote. How do I find it?
3x plus 3 equals 0.
Denominator equals 0. Vertical asymptote is where the denominator equals 0, so we solve that equation, subtracting 3 from both sides and dividing out. Gives us a vertical asymptote at x is -1. Horizontal asymptote. What's the rule there?
Y equals
1/3.
1/3. The fraction of the numbers in front of the x's. And so we can kind of confirm on our graph that that looks like about where they're supposed to be. And then our graph shows us which two corners to draw in the curves. Domain and range are the not equals versions of the asymptotes. Questions? Your homework is from 9.2. And once again, make sure you're careful with your directions, doing the specific things that those questions say to do. Sometimes they tell you to do different things. You don't have to graph all of them.